Let me read this question now. Diagram 2 shows the curves of quadratic function fx and gx which intersect the x-axis at two same points. As you can see here you have fx with the function x minus 3 square plus k, okay, and you have here gx equals to negative 3x square plus in a bracket m minus 4 close bracket x minus 15. Okay, so the question asks us to find the value of k. So that is for the question part A. For the question B part 1, they ask us to find the value of m, okay, and then followed by question B part 2, hence find the coordinates of the maximum point of gx by using the method of completing the square. So this is the overall question of question number 4. Okay, so without further ado, let us start our discussion for the question 4 by beginning with the part A. Okay, so part A is considered a very short question. Okay, we're not going to take much time. So we are required to find the value of k. To start off, what you're going to do is we're going to write the function fx in the working here. So from here, fx is equals to x minus 3 square plus with k. Alright, so from here, in order to find the value of k is actually very simple, guys. Okay, in order for you to find the value of k, the first step what we need to do is we need to expand the whole fx equation. So let us expand the whole fx equation. Okay, so from here, so when we expand the whole fx equation, so from here you get is x square minus 6x plus with 9 plus with k. So from here, how are you going to find the value of k? If you think that you don't know, okay, please take a look at the diagram carefully. The question has already gave us one of the hint, which is the y-intercept. Okay, we already have the y-intercept 5 over here, okay, within the function fx. Okay, so what we can do is we can use this y-intercept, and then later on we're going to compare with this y plus k value, and then from there we're going to get the k value. Okay, so how are we going to do that? Very simple. So we're going to set our x equals to 0, okay, because it is a y-intercept, right? So technically your x value will be 0. So from here, when x equals to 0, so from here you have your y equals to 5. Okay, so from here what you're going to do, so we're going to insert these two values into this fx equation. Okay, so from here 5 will be equals to, okay, 0 square minus with 6 times with 0 plus with 9 plus with k. Okay, so and then you continue. So from here you get 5 equals to 9 plus with k. So to find the k, what you're going to do, 9 from the right hand side, you're going to move it to the left hand side. So from here you should get your k is equals to negative 4. Okay, so this is your answer for the question part A. Okay, very straightforward, and it's a short question. Okay, so let me underline the solution for the question part A. Okay, we are done with the discussion of the question part A. Let us proceed our discussion for the question B part 1, where we are required to find the value of m. Okay, so let us begin our discussion for the question B part 1. Okay, if you take a look at this diagram, okay, the fx and gx is intersecting at these two particular points. Okay, so they are having a common intersection for fx and gx, and recently we have already find the value of k for fx, which in this case is equal to negative 4. Okay, so from here, how we're going to solve this question is, the first step is we're going to find the x-intercept for fx. Okay, because fx and gx technically they have the same x-intercept because they are lying on the same, they are intersecting at the two same points. Okay, so once we already find the x-intercept for fx, okay, what you're going to do is later on we're going to compare it with the gx, and we're going to solve it using the SOR and POR method, sum of roots and product of roots concept, and from there we should able to get the value of m. So this is the overall idea on how we're going to find the value of m here. Okay, So enough with the explanation, so let us dive into the working now. Okay, so from here what we're going to do is we're going to substitute the k equals to -4 that we get in the question part A, and we're going to substitute into the fx equation. So from here, when k equals to -4, so from here fx is equals to x minus 3 square minus 4. Okay, so from here we're going to expand the bracket. Okay, so from here fx will be equals to x square minus 6x plus with 9 minus with 4. Okay, and from here you should get your fx is equals to x squared minus 6x plus with 5. Okay, so from here, since we wanted to find the x-intercept, we set our fx equals to 0. Okay, so from here, when fx is equals to 0, so from here your x square minus 6x plus with 5 will be equals to 0. Okay, so from here you perform the factorization, so you should be getting x minus 1, okay, and then times with x minus 5, okay, equals to 0. Okay, and from here you get 2x intercept where your x equals to 1 and x is equals to 5. Okay, so we are done with the step number 1 is by finding the x-intercept for fx, because technically fx and gx, they have the same x-intercept, right? So it is important for us to find the x-intercept first. Okay, so once we're done by finding the x-intercept, so the next step what we're going to do is we're going to use this x-intercept value and we're going to compare with the gx function. Okay, so let us write down the gx function. So from here gx, okay, is equals to 3x square, okay, plus, okay, inner bracket m minus 4 close bracket x minus with 15. Okay, so before proceed to do the SOR and POR calculation, it is important for us to set our coefficient A is equals to 1. So how are you going to set our coefficient A equals to 1? So we divide the whole equation by -3. Okay, so from here gx is equals to, okay, -3. Okay, so you factor out the -3. So from here you left with x square minus with m minus 4 x over 3. Okay, and then plus with 5. Okay, all right, so from here let us continue our calculation for SOR or POR. For POR, it's very obvious. So 1 times with -5, you should get is, 1 times with 5, you should get is 5. Okay, very straightforward. So now, since we are going to find the value of m, so we're going to use the SOR concept, sum of roots. Okay, so from here, calculation of sum of roots, 1 plus with 5. So this is the roots that we got. Okay, 1 plus with 5 will be equals to, okay, since in the quadratic equation the coefficient of b here is negative, so when you're using in the SOR it will be positive, the other way around. Okay, m minus 4 over 3. Okay, so I hope you could able to recall the SOR and POR, the equation, guys. Okay, the general equation, so as it is very useful for us to solve this question. Okay, so from here 1 plus 5 is 6. Okay, from here m minus 4 over 3. Okay, 3 times it's 6, you get is 18. So from here 18 is equals to m minus 4 Okay, so from here you should get your m is equals to 22. So this is your answer for the question B part 1. Okay, are we clear about this? So I hope my explanation is clear for you guys. Okay, for the question B part 1. So from here, let us proceed our discussion for the question B part 2, where we are required to find the maximum point for the gx by using the method of completing the square. Okay, but before that, before doing the completing the square, so the very first step what we're going to do is we're going to substitute the m value that we have recently find just now. Okay, and then we're going to substitute into the gx equation. Okay, so from here, when m is equals to 22, so from here your gx will be equals to negative 3x squared plus with, okay, instead of writing m, so we're going to write 22 minus 4 close bracket x minus with 15. So from here you get your gx is equals to negative 3x squared plus with 18x minus 15. Okay, so once you are clear, there is no more variables. From here, now you can proceed to do the completing the square method. Okay, let us do it step by step. So in order for us to do the completing the square method, make sure that your coefficient of a in a quadratic function must be equals to 1. Okay, so from here, the negative 3 we factor out. Okay, and then you're only left with x squared minus 6x plus with 5. Okay, close square bracket. Okay, and then continue our next step, negative 3 square bracket x square minus 6x. Okay, and then plus with negative coefficient of b divided with 2 squared, which is in this case will be negative 3 squared. Okay, and then minus with negative 3 squared plus with 5. Okay, I repeat again, plus with negative coefficient of b divided with 2 squared. Okay, when there is a plus here, there must be a minus over here, and that's why it's called completing the square, guys. Okay, you are balancing both sides. Okay, minus with negative 3 square. Okay, close bracket. So from here, what we're going to do is this x square minus 6x plus negative 3 square, positive negative 3 square. So anything you square, you get positive. So from here, when you square this, you get 9. So x square minus 6x plus 9. So you can reduce into a quadratic factor of x minus 3 square. Okay, so for the next step, what we're going to do is, so we're going to reduce this into a quadratic factor of x minus 3 square. So from here, we're going to reduce this as x minus 3 squared. Okay, let me write this properly. Okay, x minus 3 squared. Okay, and then minus 9 minus 5, I mean plus 5, close bracket. So how you get your negative 9? Okay, negative 3 square, you get 9, and then you times with negative over here, so that's how you get negative 9 plus with 5. Okay, so from here, negative 3, okay, square bracket, x minus 3 square. Okay, and then you get negative 4. Okay, so negative 9 plus with 5, and that's how we get negative 4. Okay, for the final step, what you're going to do is we're going to times the negative 3 coefficient back into this equation, into the quadratic function equation. So from here, you should get negative 3 bracket x minus 3 square plus with 12, and that's how we get from from negative 4 into positive 12, because this negative 3 you times back into this square bracket equation. Okay, so for now, I hope it's clear for you. Okay, so just let me write here gx equals to gx equals to okay, last one. Okay, so in order for us to find the maximum point, you need two important information. One is the axis of symmetry and another one is the maximum value. Okay, maximum value is very straightforward. We can get from here. So from here, maximum value is equals to 12. Okay, now the axis of symmetry. Axis of symmetry. So from here, x minus 3, so we set it equals to 0. So x minus 3, we set it equals to 0. So from here, you get your x is equals to 3. Okay. So for the maximum point, you just use the axis of symmetry as your x coordinate and maximum value as your y coordinate. And that's how you get your maximum point. So hence, maximum point in this case will be equals to 3, 12. Okay, so this is your answer for the question B part 2. Okay, so let me underline the solution for the question B part 2. Okay, let me scroll the question up. Okay, so we have done with our discussion for the SPM 2021 paper 2 question number 4. If you like this video and if you find that my explanation is useful and make you understand better, so please like this video and subscribe to the channel for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Okay, thank you everyone for your support, and as always, I'll see you in the next video.